All right, let's try to graph this rational function. So first off, I notice that the degree of the denominator is greater than the degree of the numerator. So I know I'm going to have a horizontal asymptote at y equals 0. And I know I'm going to have vertical asymptotes at any zeros of the denominator. All right, so we should factor anything that we can factor. So I notice that the denominator is a difference of squares, so it's going to factor as two conjugates, x plus 3 and x minus 3. Okay, so right off the bat, I know that I'm going to have vertical asymptotes. Well, we'll see, we'll have one vertical asymptote here. Notice here that we have a common factor. We have x plus 3 on the top and x plus 3 on the bottom. Okay, so those common factors can cancel out as long as x is not negative 3. And I'm left with 1 over x minus 3. So this function is undefined when x is 3 or when x is negative 3. Now here, we know that we'll have a vertical asymptote at 3. Okay, so let's go ahead and put that in. So I know I'll have a vertical asymptote at 3. All right, but this function is undefined at negative 3, but I'm not going to have a vertical asymptote at negative 3. When your common factors cancel out, what's really going to happen is you'll have a hole in your graph. Okay, and that's because these two functions are equal everywhere except when x is negative 3. So when I graph this function, it's going to look exactly like this one, which only has one vertical asymptote, except for one little point. And that one little point's negative 3. So it's going to look exactly like this, except there's going to be a hole in the graph at negative 3. So let's mark that. And let's see what we get. So if I plugged in 4, let's say, to this graph. So if I put in 4 here, 4 minus 3 is 1. And I put in 1 over 1. I get that. And then I can plug in, say, 5. 5 minus 3 is 2, and I get 1/2. And you know exactly what's going to happen. It's going to go right out this horizontal asymptote. And you know what will happen here. It'll go right up that vertical asymptote. All right, what about the other side here? So say I plugged in 2. If I put 2 into this function, 2 minus 3 is negative 1. So I would end up with negative 1 here. Let's say I plug in 0. If I plug in 0, I'll get negative 1/3. Should be about right here. And you see what's going to happen. It's going to go right out this asymptote. Except for one little point. There's going to be a hole in my graph at negative 3. So that means, just kind of see if I can draw this a little bigger. Let's move my negative 1 down some. So I'm going to have a hole right there. And it's still going to go out this asymptote in this way. So there's a hole in my graph here at negative 3. And of course, this will go just like that. All right, so my graph looks exactly like this graph would look, except for one spot where we cancel those out at negative 3, and there's a hole in the graph there. All right, let's say we want to know the y value of this hole. Okay, so to do that, I can't plug negative 3 into this one because it would be undefined. That's why the hole's there, but I can plug it into this. If I put negative 3 in here, I got negative 3 minus 3, that's negative 6. So this hole is right here at negative 1/6. So at negative 3, negative 1/6, I have a hole in the graph. All right, let's try one more example. So again, we should factor anything that we could factor. So the top up here will factor as see, I'll move 3x and an x, and put a 4 and a 1, and a minus and a plus. Let's double check that. It's 3x squared minus 12x plus 1x is minus 11 and minus 4. And then on the bottom, x and x, 5, minus 5 and minus 4. Looks like it'll work. Minus 4x, minus 5x. That works. Notice then we have a common factor. So we can cross out those two. And get 3x plus 1, that makes minus 5. All right, so this function is equal to this function everywhere except one point. This function is equal to this function everywhere except when x is 4. So I know I'll have a hole in my graph at x equals 4. Right. Here, the degree of the numerator is 1, the degree of the denominator is 1. So I know, put my understood 1 in there, I know that I'll have a horizontal asymptote at 3, and I'll have a vertical asymptote at 5. Right, so let's see if we can make a graph. So a vertical asymptote will be at 5. And I'm going to have a hole in the graph at 4. I know I have a horizontal asymptote at 3. So horizontal here. Let's see if we can make a graph then. So if I put in 6 to this function, let's say 3 times 6 is 18, plus 1 is 19. And 6 minus 5 is 1, so I get a 19. I get something positive up here. So it's going to look something like this, which means this one is probably going to look this way. So let's put in a 4 and see what we get. So if I plug in 4, 3 times 4 is 12, plus 1 is 13. 4 minus 5 is negative 1, so I get negative 13. Remember, this will be a hole in the graph. 4, negative 13. And it's going to go out that asymptote and down this asymptote. Let's make sure right here, if I put a 0 in, let's make sure it's really up there somewhere. So if I put in 0, I get 1 over negative 5, which would be negative 1/5. So I better have moved that down a little bit. Don't want to draw my graph that wrong. There we go. That looks a little bit better now. Awesome. But still, it should go out this asymptote. So if I plug in something like negative 1,000, you should get something really close to 3. And you would, yes. All right, so there's a rough graph of that function.